In the previous unit, we saw that data space consisted of two things: data on measurements or categories, context and context attributes, and the probabilistic relationships among them, depending upon whether we are willing to make certain assumptions. Our objective as data detectives is to investigate the order and randomness in a system, allowing for contextual variability. To do this, I will offer another useful concept: the stack. A stack is simply the collection of apps to create, explore, and analyze data space. It is the workflow to get from data to knowledge. This unit is essentially a roadmap for the topics we will cover in this course. We will first go over code enabling us to capture data online and import it into our laptops using R and Python. For this, I'll go over examples from both environmental science and sports. We need some structured and systematic way to store and manage these data. For this, we'll rely on R, Python, and MySQL. Data is very rarely tidy, and we'll go through some code to help format and structure the data. If we've done a good job gathering and structuring the data, then we will have built the data space we need to slice and dice our data, that is, to play with our data, so we can figure out what the data patterns are telling us. Before we start building computational models, it's always useful to visualize the data as they are. In the previous unit, we saw how important it was to try and see whether the data actually followed a probability distribution. We will likely spend most of our time in this course talking about analysis. Specifically, we're going to look at ways we can evaluate different model forms, develop the models that seem to be the most promising, and evaluate how well our models actually perform, that is, how well it produces results that are similar to the actual data. Once we've developed and run our models, we'll have to figure out ways to effectively communicate these results. For example, this is a plot of watersheds in the county I live in, which is right outside Washington, D.C. The watersheds shaded in red are those that, based on my model, are most likely to generate unhealthy amounts of algae. A manager who cares little about data analysis can easily understand this graph because it clearly indicates to her which watersheds she should worry about. Finally, if we have time, we'll talk about how we can implement all this work in the cloud. We want to prepare ourselves for the probability that we will have too much data to analyze on our laptops. Doing our work in the cloud will allow us to be data detectives with virtually limitless memory and processing power, because we can always add RAM or parallel process our algorithms across multiple nodes in the cloud.